I've recently become a bit obsessed with the idea of generative design and topological optimization, and in this video I'm going to take my first few baby steps to this amazing new world. Watch on to find out more. If you listened to that intro and wondered what on earth is generative design and topological optimization, then you're probably not alone. It's been around for a few years now, but it's recently come to the fore since the likes of Solid Edge and Autodesk Fusion 360 have released their own topological optimization packages. And what it is basically algorithmically generated design. But what on earth does design by algorithm actually mean? Well, to understand that, we need to take a step back. The traditional workflow is to design an object, draft it out in CAD, maybe run a finite element analysis, we'll call it FEA from now on, and look at the results of the FEA, be that von Mises stress criterion as it is here, but it also might be any number of other stress or displacement measures. The designer then will typically make changes to the part to optimize for whatever conditions he's trying to test for in the FEA software. Now, the difference between this and algorithmic design is it basically takes the designer out of it once they've specified the boundary conditions. This amazing clip from Autodesk from their new Fusion 360 Generative Design plugin shows the optimization of a quadricopter chassis, and it looks very natural and organic. It almost looks like it's evolved to meet the criterion set out in the FEA. And that is of course exactly what's happening. This is a little test that I've run with a Solidworks plugin called Truform Xpress from GRM. I've created a little flat top cone and then run a simulation with a force acting down on the top of it. Now from there I tried a number of different things. I ISO clipped it, which is a technique where I can see the maximum stress. And even though that's a great visualization tool, it doesn't tell me exactly where I need to thin out material. So I ran the Truform optimization wizard and it gave me a really strange organic shape which I wouldn't have come up with on my own. Now, as it happens, this produces an STL which can be 3D printed or manufactured via some additive process, and here we can see there's a massive weight saving. And these kind of designs are typical of generatively or iteratively or algorithmically generated designs. They tend to be organic looking, quite strange, look like maybe bones or a root system that have grown out of nothing, and they can be very difficult to manufacture without additive manufacturing systems. Now, Truform Xpress actually provides a range of tools in some of their advanced products where you can sketch over the top and actually prepare the part for a subtractive process like milling or turning. So this is the result of the optimization of that super simplified wishbone arrangement that I did an FEA of. Now it's come out with something really organic looking, it's bumpy, it's fairly irregular, but it gives you an idea of the kind of shape that's required to have the perfect optimization. So underneath you can see there's a little hollow on both sides, and also seeing as I gave it a loading from one side, it's given an asymmetric sort of support network. Now, one thing it hasn't done is it hasn't given support for the back two holes, but that's simply because I specified too great a mass saving in the optimization criteria. Now, I am interested to do this for real for the OpenRCR wishbone, and I'm going to do that in a separate video, and I think it'll come out with some really interesting and measurable results. But just for the sake of this video, I'm going to 3D print this model and get it in our hands and see what it actually looks like, because they are quite strange, and you can possibly see the reason why this does lend itself better to additive manufacturing. But do keep your eye on this generative design and topological optimization movement. There's a lot of hype around it at the moment. Here we are, we've got an article called The Alien Style of Deep Learning and Generative Design. There's a lot of buzzwords. It's linked to evolution and artificial intelligence and machine learning and all kinds of bleeding edge but sometimes irrelevant technologies. It's basically designed by algorithm. It responds to boundary conditions that you give it at the moment. I have no doubt that this could be massive and it will change the face of engineering design, but at the moment it is just another tool for the design engineer. The thing that I'm looking at the moment is Autodesk Fusion 360 has generative design as a plugin for their ultimate version. At the moment there's only £175 a month in order to get up to that level, but typically these tools do filter down into the hobbyist market, and I wouldn't be surprised if this does come along to an affordable price point sometime soon. Similarly, Solidworks has a plugin in one of their simulation premium, I believe, modules, but we're talking thousands and thousands of pounds. Truform Xpress, if you have a premium installation, is a free download, but it's not cheap to get into and it's not hugely stable. But Solid Edge, I have heard, although I have no experience of, is a platform on which generative design is accessible and free, I believe. Do let me know if that's not true, because I intend to check that out. But Autodesk, I have a lot of love for that company. If anyone can do it and bring it to the masses, then this company can. So keep your eye on their official feeds. Finally, channel of the week is someone much bigger than us. It's TFI, nearly 28,000 subscribers. And I found out about this channel when looking at a 3D mouse. I'm recently invested in a 3D Connexion SpaceMouse Pro, and it's a fantastic piece of kit. I'm going to do a review on it on the channel first, but this particular channel has loads of interesting content on both the SpaceMouse Pro and mainly Autodesk products, but it's a fantastic resource. So if you like these videos and you want to find out more about generative design, then do subscribe, like and comment, and we'll see you next week.